Hello, everybody. How are you doing? Okay, so let's wait a couple minutes for everybody to join. And if you can please log into Canvas and check out the lab for today. Okay, let me get my lab open. Oh, go ahead and go into screen share. Okay, so welcome back to CIS11. Today we are going to do lab 2. You will find this on Canvas on the lab 2 page. After the session, I will post the video in case you miss anything and you want to take a look at it again. So in this lab, we are going to use LC-3. As I mentioned in the last session, make sure that we have the LC-3 simulator, and you can find that on the LC-3 resources. When you click that link, you're going to get an executable. Make sure you install it. And if you have it installed, the folder that you need to access is on your C drive if you're using Windows system. Okay. All right. So let's take a look at some of the information we need to understand before we write this lab. So LC3, the word size that you're going to use is going to be 16 bits. And we are going to use registers R0 through R7. Think of those as temporary memory. Those are just location where you can put data in. You can move things around from those registers. And so there are 8 registers. R0 stands for register 0, and then that goes all the way through R7. You can reuse the registers when you when you add things, and then you can move them in and out. So we are going to be working with various opcodes, and there are 16 possible opcodes in LC3. Those are just instructions for the system to execute certain things, such as adding a value or loading a value. And all your data is assumed to be stored in the 2's complement representation. So there's no separate unsigned arithmetic. So we are going to treat everything with positive values or unsigned. And if we need to subtract anything, we need to use 2's complement. Now, we will work with input and output today, where we would need to enter a certain value. So you will see some of that in the code. So your opcode, some of it is listed here. And you always want to start your program with the origination address. That will be the first line. In the system, what that will do is it's going to start your code at a certain address, which is memory address location. And by practice in LC3, we always start with 3000 or hex 3000. You don't want to start it in the later addresses because it's so far down that you can't access some of the other memory address. So hex 3000 is where we always going to start our program. At the end of your program, just like how in C++, you would have return 0 to finish out your program and release the resources back to the system. At the end of your program, you are going to use n or .n. That's going to terminate the program. And then the BLKW that you see there is known as block word, and you can actually allocate it a number of words using the n value, right? So if I can say block word and 5, that's going to give it 5 16-bit words for storage. So in the case where you work with arrays, that's what's necessary. Now to initialize value, like how you would use int variable with an equal sign to initialize a certain value, here we can fill your label or your identifier with a certain value, and we can do it with hex, we can do it with decimal, and so hexadecimal is indicated with an X, and decimal we're going to use a hashtag. Okay, so you can fill something, and all that is going to link that value to the label or the identifier. So when you fill, what it will do is going to take 16-bit or one word to initialize whatever the value you put in there. Now, keep in mind that if the value is larger than the 16 bits, then we have to consider using block word for storage. When you're handling string text, we need to use .string with a Z. And in the string, for the string, you have to put it in quotation mark. And what that will do is gonna allocate the n to indicate the number of characters that you're gonna have plus 1 because it's null terminated, very similar to C. So if you have a string that has 5 characters, it's going to allocate 6 location, 5 for the 5 characters with the null termination. So that's your opcode. That's what you need to give the computer the instructions. And then your operands are usually addresses or data. Okay. So the way that we write it, your label is going to go into the front. Then your opcode, and we don't always use label, of course, that's optional. Opcode is required, that's mandatory. So you have to tell the system what to do. And then your operands, what it's doing with or what kind of value it's using. So your operands is mandatory along with your opcode. Your comment is using a semicolon. So simply the simulator is going to ignore whatever that you're commenting out. So we can add the comments as we go to note what we're doing at that line or that section of your code. As I mentioned, when you're using a decimal value like integers, you're going to use a hashtag in front of the number. And for the hexadecimal, often we would use this as values or memory addresses that will indicate with the lowercase x. Your label, you can place this at the beginning of your line, and that is just a symbolic name or an identifier. We can use that label to identify a section of code or a certain location in the memory, like how we would treat variable in C or C++. Okay, so the example that you see there is if I want to add values from the register, I first have to give the register the value, but it would be something like this. Now, when you look at this, I say add register 0, register 0, register 1. Register 0 here and next to the opcode is going to be the result, the storage, the final result. So it's going to take register 0 and register 1, add those values together, and then store the result in the register 0. So the location, the destination where it's going to end up with the result is going to go to the front. Okay. So on the next line here, I'm adding the decimal 5 with whatever the value is in register 0, and then I'm going to store it in register 0. Okay. And then the next line, I'm going to take the hexadecimal A, add it to whatever is in R0, and then store it in register 0. And that's how you read a line in LC3. Okay, any question? All right, so the next part, it talks about pseudo instructions for trap. And when you simulate this, you do see that it shows you some trap values. So when you halt the program, this is the same as system halt in C or C++. In the back for LC3, on your low level, it's going to do a trap with the hex 25. So what that will do is it's going to halt the execution for that task, and it's going to print your message in the console. And when we write the program, you do see this in the code. So I want to make sure that you understand what that means. When you need to have an input, you are going to write the code in. And in the back, that's equivalent to what trap hex 23 is. And we will expand on this later on, what trap means and what that value means on the stack. Then what this will do for the in is it's going to print the prompt on the console. It's going to wait for the keyboard input. So we're going to have the input. And keep in mind that in only records one character. So it's going to wait for that one character. So if you ask the user to enter a number that is one character, you're going to use an in. But if you ask the user to input multiple characters, you have to use a different opcode. Okay. So now when you take an in, it's going to put it automatically on the first register, so register 0. If you only want to store the input, you have to make sure the R0 is clear. If you want to use the input with the value that already exists in R0, you can just simply introduce using an in. But I normally clear out my register, and we would use an AND operator to do that. So we would clear it out before we introduce a new value to that location. If you need to output onto a console, we can do an out, and that's going to be trap hex 21. And what that will do is when you do an out, it's only going to display one character. And keep in mind that your system stores everything in binary. When you do an out, it converts it. We need to convert it. We have to encode it to show. Otherwise, you're going to get something really funky and you don't know what that means. So what that will do is it's going to write one character from register 0 to the console. That's how it's going to display. Okay. When we do a get C, that's going to read one character from the keyboard. That's slightly different than the in, because the in prompt on the console, and it's going to read the one character from the keyboard. And again, it's going to use register 0. So that first register, if you're going to have a lot of input and output, make sure that you look at what's already there, right? If you want it to empty, you have to clear it out. Okay. Then if we want puts, puts is going to write a whole string. So if you want to display the entire string, we are going to put it, but we have to fill the strings and give it an address so that way it can retrieve it. Okay. Assembly is very physical, right? We have to really see what the machine is doing step by step to really understand how it's operating and it's executing certain instruction. Any question with this? Okay. Also, I put here that when you see something like string like this, high, you need to make sure that this is going to get converted, because everything is going to be raw number. So we want to make sure that it gets converted. If it's going to be number, we have to make it into ASCII. So if you haven't downloaded the simulator, make sure you do that, okay? And install it on your system. And you can run it from USB. However, I encourage you to be able to use the simulator installed on your system. Now, for those of you who are using Mac OS, right, I put a link on your first module for LC3 resources. So the downside of using the online simulator is that there's no editor on there. So you need to use some form of editor like Sublime. You can use Visual Studio, but all your assembly file needs to be saved as .asm. Okay, for all the labs from now until the end of the semester, every single code file is going to be .asm. So the link for the online simulator is located here. You can find others. Okay. Now, if you're using Mac OS and you're using online, or you're using Chromebook and you're using online simulator, you have to write your code from your computer using a text editor and save it as a .asm. Then you're going to upload it, okay, by clicking assemble, and then you're going to drop the file in there, and then you're going to click assemble. And that's how you're going to assemble your assembly file, okay? And then once it's assembled, then you can run by clicking the run button, okay? And that's how you're going to use the online simulator. Now, for those of you who are using Windows PC, after you install, you are going to have the LC3 folder like this. So this is where your editor and your simulator exists after you install. You're going to open that up and you're going to see edit. That's your editor. And after you write your code, you can simulate your code. So this is where you're going to write your code, is in the editor. Okay. Now the downside of this is it doesn't have line numbers. Okay. You can write your code on another editor and save it as a .asm file. I normally put it in the folder of my unit. And so that way you can find it, because when it builds, it's going to have 3 files. Okay. Any question? Okay. So what we're going to do next is we are going to write a hello world program. And you can use the editor directly, or you can use a different text editor, but you need to save it as .asm. So I'm going to load my file, and so that way I can explain to you what each of these means. Okay, so I have my file written here. Okay, and I'm sorry if it's a little small, but you can see the screen capture. It's exactly that. So at the top, we have a bunch of comments, and I normally put what exercise that is. Now, at university level, they're going to expect you to put some information about your program. So for this class, we can practice doing that. So I just put that this is a Hello World program. The description for the program, what is it displaying and what is it using? So I put LC3 program that display Hello World. So every comment line, you have to put a semicolon in the front. What it's going to do is going to ignore them when it assembles. Now, also by practice, we want to put what is the type of input we have. So we don't have any kind of input in this program. We're simply going to output. Then on the following line, we're going to have an output. And an output, we're going to output this entire string. Hello world, this is my first LC3 program. There are no side effects in this particular program, so we put none. And you should put how this program is going to be ran and simulated, because most people don't know how assembly is ran and simulated. Okay, so I put that run, and this is for you mostly. You are going, after you write your code, you are going to assemble by clicking this .asm. Okay, after you save it, and then you are going to use the simulator. When you use the simulator, you're going to load your object file. Okay, so for those of you who are using the online simulator, you simply upload your .asm file, click assemble, and it's going to assemble the object file for you. Now for For us who are we're using the software, after you assemble, it's going to give you the OBJ file. That's what's going to be used in the software for the simulator to be able to run. Okay. All right. Any question? All right. So after our comment, we have the first line, and the biggest part with students starting assembly is just like any programming language is syntax, right? Syntax is the way that we write our code. So if you miss a period in front of dot or origination, it's not gonna assemble. Okay. If you have a typo, right, it's gonna throw an error and it's gonna show down here. And so here we have the origination address, and we want to start at hex 3000, like what we said. You don't want to start later in the program. This is where we would use. And most assembly, you would have to say where it's going to start. So what it will do is going to go and set up that location, and every instruction, every line that you add, it's going to load it into the memory address, and you will see it. Okay. And LEA is a way that we load the address to a string. And we'll talk more about this in the next couple of weeks, what it's really doing. Okay. And as we are dealing with a lot of the output, we have to use register 0. You cannot use other register if you're outputting that string. Okay. So here we are going to load effective address for the string. And later on, we're going to define where that is and what that is. So we are going to do an LEA register 0. And we're going to use the label called HW, hello world.
Is R0 the same as the accumulator in other processors?
Say it again.
Is R0 the same as the accumulator in other processors?
Yes. So we're going to load the address of the string, which we later define. And in, I know Microsoft ASM, there's a section for data, just like how when you declare a variable in C++, you normally do that at the top, right? In assembly and for LC3, you define the data on the bottom, okay? So after the first line, we load that address to register 0. Then we are going to do a put. So this put is going to output the entire string onto the console for you. And then after that, we simply have a halt. So we end the program. Now, I'm sorry, end the execution. And next is going to be the data section. Okay, this is where your fill and your strings are going to go. Okay. No, it's not case sensitive, but I like to use all capital for my code. And then my comment, I use lowercase because it's just readable. You know, so, but yeah, for this,
just keeping it clean, right?
Yeah, just keep it capitalized so it's visible. By practice, you should keep it. In assembly, you look at any assembly program, they use all capital letters. So, okay. Then for our data, we're going to fill the string. So we got to make a label, right? An identifier where it's going to fill, it's going to associate that to an address, and it's going to fill that string. So what we're going to do is we're going to give a label name, and you can use any unique name. Normally trying to make it short, right? And meaningful to your program. And then we're going to do a dot strings with a Z. And your string needs to be in double quotation mark. And then after that, we're going to do a dot end to end the program. Okay. So this one, just to output one line, as you can see, it requires 1, 2, 3, 4, 5, 6 lines. Okay. So in assembly. So, you know, something in higher language that takes maybe a couple of lines, this will take about 2-3 times or more. So after you write down your code, okay, you can, if you're using the app, the software, you can click the .asm file button here, or you can click translate and assemble, okay? And once it's assembled, you're gonna find, sorry, 1 second. Let me go back to my folder so I can show you where you store that file. Oh, I forgot, I skipped a step. Go File, Save As, and you wanted to name it hello world.asm. Like that. Make sure it's .asm. So here is where we would distinguish between a text file and an ASM file, right? Because if you don't give it the file extension, it's going to make it a text file and you cannot assemble the text file. So we would save it as a .asm. Then we can click the ASM button to assemble. And so once you have it assembled, it's gonna give you these object file, the symbol file, the bin file, and the hex file. Okay. So it's gonna assemble and give you those files. And the OBJ is what we need to be able to simulate your assembly program. Any question with the first exercise? Okay. Now, if you're using a text editor like Notepad++ or Sublime, again, just save that file as a .asm, but make sure that you put it in a folder, like, you know, your class folder, where you can find the files, because when it assembles, it's going to add the object file at that location. Okay, otherwise you cannot find it. All right, so once I have my program saved and assembled, then I'm going to go to my my simulator and open that up. And it's going to look like this. Okay. Now, when your system has nothing, everything is 0 like this. So the way that they made this is it's simulated to be all 0. You can also clear it by going File and reinitialize the machine. What that does is it's going to put it back to the 0 state again. So once in a while, when you write a program and it's you know, it's not responding, I normally suggest the students to reinitialize the machine before reloading that program to simulate. It's a software, sometimes it has issues. So, you know, just to clear it up, clear everything first and then load your program. Your console is on a separate window. This is where you would see the output. Okay. All right. So now after we assemble, we are going to load the file. You can click the load program button here or file, and then you can choose load program, same thing. And then we are going to, let me double check and make sure that it's the, I'm just gonna put the hello world here. Okay. And then we find the object file that was assembled for us in the, where we saved our file, and click open. And you would see that here it's going to start on the left column. It shows the memory addresses, right? You told the system to start at the address hex 3000. That's where it's going to be. And these are the instructions of your program. Okay. And as we mentioned earlier, we see the trap value here. So trap hex 22, trap hex 25, and this is before it runs. So you can see all of that. Okay. Now on the top, you will find your registers, but keep in mind that this is temporal, so that it's not gonna, sometimes the value stays there. Sometimes it, you know, depending on your instructions, sometimes it moves to other area. Okay. So after we load our program, we're gonna click the button here to run the program, or you can click execute, run, or press F5. Okay. So as it ran, you notice that now, right, your register 0 was used because the LEA in the back is actually, you know, loading these. Okay. And then, so in order to output this, right, it executed these things. And so on the left, you can see that on my console, I see hello world. This is my first LC3 program. Okay, so if you're not outputting anything, just check your syntax and make sure, right? Anytime you edit the program, you have to reassemble the program, just like how, you know, you save and you reassemble. Okay, and even when you fix one character, you have to save and reassemble. Okay, so for the first exercise, we simply do a hello world to see if we have an output. And we will talk more about the instructions in the next few weeks. We'll dive a little deeper on how, you know, how to store, how to load, what's the difference between LD and LEA and LDI and all of the other instructions. Any question? Now mathematically, right? If I look at all the instructions and specifically, and when we get a little deeper into this, you will be able to see why it's having a certain results in different area. And we'll talk about the PC and the IR and all of the other components. So in the first lab, the first exercise number 6, we simply do a hello world program. Okay. And I give you the breakdown for that. After you have saved and ran the program. Okay. Then I want you to attempt to do number 14, which is the same concept, right? You are going to load, but in this one, you have 2 strings, right? We don't want a long line with a bunch, you know, like a long line with a bunch of strings all together. It just aesthetically, it's not going to look good. And sometimes that doesn't make sense to the user. So you can also use the /n as your carriage character, right? That you can, a lot of the things very similar to C, where you can break up separate line. Okay. Let me find my okay. Any question regarding the Hello World program before we move to the next one? So after you successfully ran your program, I want you to take a screen capture. Okay, if you had my class before, you know I like to look at screen captures when I grade, so I can see. So I need screen capture of your code and your output. Okay, so you can put all of those windows together and take one screenshot, put it on a document, and make sure that you submit it as a .docx or a .pdf. Now, you don't have to take separate images and upload them. You can put all the images on one document and upload one time. That's probably going to save you time, because I do see some students submitting, 5-10 different pictures, but put those pictures onto one document so you just upload one time. Okay. Any question? Okay, so we know how to do screenshot, correct? Okay, alt print screen for Windows, and then I think for Mac OS there are separate. There's also control options to do that. You can snip. There are a lot of different ways you can screenshot for me. All right, so let me. Get back to my editor here. And then, okay. So for task 14, number 14, it's the second exercise. We have to output 2 strings. And I simply duplicated the first Hello World program, but I wanted to make sure that it's able to handle 2 strings. So I comment at the top, exercise 2, second program, the description of my program. What kind of input I have, none. What kind of output I have, the 2 strings. This is my second program, right? And then a new line, I am learning assembly programming. Okay, no side effects, and the same instruction on how to assemble and run. Like the first program, I would have the origination address. So we would say .org hex 3000. We always start there. And then we are going to load the first string. So we are going to do an LEA, and you would always use LEA when you're dealing with strings to load it to the register. Okay. So what you're doing there is you're putting it onto the register so the processor can see it. And then it's going to take that and set it through output. After I load it onto the register, I'm going to put, because I want to show that on the console first, the first string. Then I repeat the process for the second string. But I'm using a different label because the string is different. So again, I'm going to do an LEA, register 0, and then HW2. You can name it anything you want, of course, right? Just make sure that it is correlated to the bottom data section here. And we are going to, again, load the effective address for the second string. And after that, we can put the second string. So those strings, the only area that those strings are really permanent is the data section. But as you execute it, it's gone, right? 0, you took that, you output it, and then you load it again with a different string, and then you output it. And then we're going to halt the execution. And I should recomment this, not end program, but stop execution. And then for the data section, I normally space it a little bit so I can see the difference, because when you have a longer program, it's just harder to read. So I have the first label, and I have dot strings because I'm using string, and then put your string in quotation mark. This is my second LC3 program, and you want to do the new line carriage there. Okay, so it's going to be able to understand that it's going to separate that line with the next. And then for the second string, I simply have the label in the front, then my opcode, then my data, or my operand. Your operand gonna always go last. Your opcode is after the label. Then at the end, you are going to do a .n to finish up that program. And that's how you can do 2 strings or multiple strings in LC3. Any question? So not too bad, right? We went from 6 lines, we add a few more lines for our second string. Then I can click translate and assemble or click the ASM button after I save it as a .asm. So file save as. And on this, as you saw, I save it, you can save it any name you want, unlike Java, right? You can just save it however. So in my case, I save it as exercise 2 and make sure it's .asm and then assemble. Okay. So after,
Professor?
Yes.
What is the line .origx3000 mean?
Yeah, I
Yeah, that
touched
line.
on this at the beginning. That is the origination address. That's where your program is going to start in the memory.
Oh, okay. Thank you.
Yeah, you always have that program. I mean, that line on top of your program, every single LC3 program. And, we want to use hex 3000 because that's just the standard for LC3. Okay. Now, if you use a later address, it's gonna load farther down, and you don't want it too far down because in some, there are instructions that's using closer up. So when you simulate, right, to start, when you load it, it's gonna show where that program actually starts in the memory, in the storage. Okay, see? Right here.
Oh, I see. I see.
All right, so after we assemble, then we can open up our simulator. And those of you who are using the online one, you just upload your ASM file, click assemble, it's gonna assemble it, and then it's gonna simulate by clicking run to simulate, okay? But for this, you have to open your file, and then you are gonna see your instructions, where it starts, okay? Where your labels are. Okay, so notice that after your instructions, that's when that's gonna be the location for your first label. Okay. And so on. So now you can go to a certain address by doing a jump to. So if I need to go back to 3000, I can just put hex 3000 to the jump to, and it's gonna bring me to the right area that I need to look at. Then we are going to run this program after we load it. Okay. And then coming back here, right, here's my console. I see both of my strings are being displayed. Okay.
Professor,
Yes.
this like the way your screen is right now, is this what we want to screenshot?
Yeah.
Upload to the
So
lab?
yeah, like this is fine. Put code, output. Yep.
Oh, okay. All right. Thank you.
Mm-hmm. Other questions? So take the first program, which is Hello World, and we use the same concept, right? We load and to register 0 with the label and for one string, and then the second string we load again to register 0 with a different label, and then we got to make sure that we declare those labels, right? What they supposed to store as strings, and that's simply it. So what you see here is now you're able to do multiple strings, and every string that you use, you've got to reload and put. and then declare. So every assembly language is different, of course, right? There's some similarity across some versions of the language. This is used in the university quite a bit because it's similar to, other languages out there. If you use Microsoft ASM, there are more instructions, and you also have to set flags and other things. But the practice is that you would have a data section in all programming languages, and you would have, functions or areas for the function on how it's going to execute. And you want to also tell it where it's going to start, which address it's going to begin with, because all it is just associating the values that you set to a location in memory, and the instruction is going to put the instructions to the area of the memory so it can retrieve it and execute it. And at the low level, that's what happens. Questions? Okay. So as you complete number 4, okay, take a screenshot for your code and your output from your simulator and your console. So I want you to start understanding what each line means. So comment to how you want to know what that line means. Okay. I did use comments in the screenshot to show you, but if you want to add your own comments so you would know, that will be helpful for you. Okay. And all register can be reused. That's why we only need 8. So there are times that we're going to reuse register. There are times that we don't reuse register. So if you want to have a static value that stays the same, you can always reference it. You don't reuse that register. But if you want that register, you already moved the data out of that register, then you can reuse it. Okay, so we want to make sure that we effectively use resources. Any question with the second program, number 14? Okay. For the next program, we are going to touch on adding instruction, and we emphasize quite a bit on how to work with binary, hex, right? Number systems, working with 2's complement. I mentioned the computer only adds. So in LC3, we're going to apply the concept that it only adds. You are going to use add instructions. So when you multiply numbers, you're going to add it many times. When you subtract, you add the 2's complement. Now you can add 2 registers, right, and store it into another register or in one of the registers so you can reuse it. Okay. And this is a lab that's actually being taught at Cal State San Bernardino. So I use the same lab, or La Sierra University, UPenn, you name it. So a lot of universities use this lab. So here it shows you that if we look at the first line here, as we looked at the example earlier, what I'm doing is it's taking what's in register 1, add it with register 2, and store the result in register 3. Okay, so the result is always going to be, the storage for the final output is going to be in the front. And it tells you here that that as all other ALU instructions, the same register can serve in both source and operand. So you can use it as what you're adding or what the result would be. Okay. So for number 15, we are going to make a program that's going to output hex value. And I want to emphasize that because when you start testing numbers and you think it's decimal, but make sure, keep in mind that this is hexadecimal value that you're gonna see. So in LC3, right, we can use decimal, but we should use hexadecimal for most part. Okay. So for the exercise 3 or number 11, we're gonna create a program, and this program is gonna print the hex value. Okay, it's gonna display the hex value. Okay. So to read this program, again, you have comments at the top. Then you have the origination address. We always start with that. Now, I want to clear register. I wanted to start with nothing in register 0. And when we learned logical operator last week, and we talked about it during our lecture this week, when you use an AND operator, you have to have 2 input. Okay. So, and we understand that when you AND something with 0, you're going to get 0, right? So if I wanted to clear out register 0 and make it all 0 inside register 0, I would AND it with a 0. Okay, so if I AND register 0 with a 0, then I have nothing in it, 0. I can clear it. Okay, so we would do AND register 0. That's what our destination. Our source is register 0 with a 0. So if you take what's in register 0 and it with the decimal 0 and store it back to register 0, you have all 0 in register 0. Okay. So basically we initialize it as 0, just like how you treat a variable and you initialize it as 0, right? Like int variable 1 is 0. That's what you're doing, is you AND that storage location with 0. Then now to really declare a variable, right, we have to make a label and associate that, right, with the register and then clear it. So what we did was we cleared the register. Now we're going to associate that register with a label. So these 2 lines are like, it's like the same thing as doing int num equals 0. Okay. In C or C++. So for the next line, I'm going to load register 0 with a label called num. And so that means that num is initialized at 0 and it is at register 0. Now, after that, I'm going to load another label called ascii to register 2. Okay. Remember that when you see text on console, it's already been converted, okay, from a value like binary or decimal, whatever, to what you could see. So we have to encode it. Okay. So here, what we're going to do is we're going to load register 2 with the label called ASCII. Okay. And next, what we're going to do is we are going to add what's in register 0, which is num. Okay. Right here is num. And to ASCII. So num plus ASCII. That's what I put here for you. And then store it back to register 0, because that's where it's going to pull for output. You have to use register 0 as the destination where it's going to store so you can out. I cannot use register 1, 2, 3 here because the out opcode can only use register 0. Okay. So with that, I would take whatever's in num, whatever's in ASCII, and I would add them together and store it in register 0, then take whatever in register 0 and I'm going to out it, right? I'm going to display it on console. So it's going to trap 21. After that, I'm going to end execution or halt execution. Then for the data portion, now I'm going to declare what num is. Okay. This one is a little tricky. So num is going to be hex 2 and ASCII is going to be hex 30. Okay. So num is going to hold the values that we're going to output, and ASCII is going to be the offset value that we apply to convert number to text that we can see. Okay, because if you don't convert, it's not going to output the right text. Okay, so how do I know what the offset is? Okay, you go to the ASCII table. Let me find a better one. Did they change this? Where's the old? Oh, okay. So this is a little confusing to a lot of the students why we're supposed to add that 30. Okay. I'm simply going to use a character A. Okay. Let's say that I have a letter A, capital A. Okay. And so if you're looking at the hex value for that, right, it's 41. Okay. Now, if we start with the hex value that's 41, then we need to convert it to an ASCII A, right? What that will be as an offset. So if you start with the number 2 in hexadecimal, so if we look at the hexadecimal number 2, okay, let's see. A hex is 2, right? Your decimal is also 2. That's going to be your start for text. But when you're going from 1 to the next value, you are going to have a 30 offset. Why is it a 30 offset? Well, if you are looking at this right here, let me make a better example for you to see. If we start with 30, okay. If we start with the hex value 30, for example, you see the first character is 0, okay? So if I use a hex value 30, it's going to output 0 onto the console as text. Okay, that's the easiest way that you can actually see. Okay. And if you're using a decimal, then it has to be 48 offset. So if you're using a hex, because we're using a hex in our program, you have to give it a 30 value. So it understands that when it's a text 30, that's equivalent to the character 0 on console. Okay. So if I have a 32 as a hexadecimal, it's going to output a character 2 on the console. Okay. So when it goes to the console, it has to go through the ASCII conversion process, and we have to tell it to do that. Now, when you do C and C++, the compiler does that for you. We don't have a compiler in this class. We are going to manually do it so you can understand what the processor does. Okay. So when you have a 0 in character, you're going to have a 30. So we have to offset it by 30. Okay. So this is why we are filling the ASCII with 30. And we initialize hex 2 as for num. So when you add these together, 30 plus 2 is going to give you hex 32. And hex 32 is going to output the character 2 on console. Okay, got it? So if you want to output the letter A, like going back to what I said, that has to be, we would fill that with hex 41, right? For your num. If you want to output, that's an uppercase A. If you want to put, let's say a J, a lowercase j, then we have to fill num with hex 6A. And you still add the 30 with the ASCII so it can convert and give you the proper character. Okay,
So
so
most of the time, the ASCII is going to be X30.
yes. We will use another technique down the line. You will see on how we can, I want to show you different ways that you can convert, but this is the simplest because of the value that you use.
Because X30 is 0, right? So
Yes, right. That's the offset. That's the difference, right? And how we look at the number and how the computer look at the number, that's what we're doing, is how we see the number compared to the computer's number. We have to see the gap and implement that gap in our program. Okay, so now once you have that program written, let me load that, open that here. I can save that. Okay, then you save and you assemble. Okay, I already explained the code. Make sure we have a .n. And after that, we can out, right? We can display the actual sum, which gives us the text. So just to simply, so if this shows you a little bit on how to convert value to ASCII, and this is why I wanted to do this. So in the later lab, you're going to have, and your project, you have to show some kind of output. And, the algorithm that you're going to implement to show the calculation as the output, right? So just to simply output the 2, it requires a few lines, okay? And you have to convert. So now, after we saved it, we are going to simulate it. And then we're going to run it. So let me get my console open as well. So many windows. Okay. So here you would see a 2. Okay. And so it should output a 2. because you can check it with your calculator, right? You take a hex 30 plus a hex 2, you should get a hex 32, which is equivalent to the character 2 from the ASCII table. ASCII 2. So if I want the number 9, what do I do? Or number 8, what do I do? I initialize my num as a different hex value, and I still gonna have to add the ASCII difference, right? The offset to convert it. Okay, and make sure that we answer this. Okay, and I pretty much gave you the answer. So what's the output of your program? Explain why the program results in the output from the previous question. So why is it outputting 2 or 5 or 6, right? It's supposed to output 2. And you can simply explain that, you know, what is stored in num, add it, what is stored in ASCII and why we add it. Okay, and to output a 2. Because if you don't add that 30, it's not going to output the 2, right? So if you want to change that program and output a different number, how would you do that? Right? We would initialize num with a different value. We're still going to add the offset, and then that's going to give you a different value. You can try it. Every time you edit it, you save, you will reassemble, and you resimulate. Any question? And if it's showing something funky, you can reinitialize the machine and then reload the program. I mean, reload the object file and then resimulate it. Because once in a while, you know, it might get stuck on, and it might have a number there, but ideally, you know, so it's like reset is reinitialize your machine, and you can click file to do that. File, reinitialize. Okay, so after we have tested our program, everything runs smoothly, we would do screenshot of code and output, and then paste that onto a document for submission later. So the purpose of these exercises is just to give you a taste of what we're going to be doing from now until close to the end of the semester and what you are expected to do with the project. And I also want to introduce different ways that we can convert ASCII along with simply use your opcode in LC-3. You get a hang of this. It's really simple, right? We simplify it. We can, you know, as long as you can understand what's happening on that line and how it's going to be able to achieve the objective of your program, then it's pretty easy. The hard part is just to visualize it, where everything is, which one stores the result, and how you're able to pull that result and get, you know, bring it from there to the output. Okay. So in the last program, we only output a value, right? And you saw that we had to convert it. In this program, the last program of our lab, number 4, is going to require input and output with ASCII. Okay. So and keep in mind that this program is going to only take 1 character input. So, later on, we're going to deal with multiple character input, right? In your project, you might need to do that. So we have to think about how we're going to be able to acquire many numbers, many characters from the user, and then how we're going to be able to put that into our register and be able to go from 0 to other register to calculate. Okay. Because the cin in C, C++, it simplified this process for us. But on the assembly level, you have to consider each character, how you're recording each character from, from the input. All right. So for number 4, I have comments at the top. And the purpose of this program is it's going to add, or it's going to create a sum. I'm going to sum 2 input. Okay. And for the input, we are going to use ASCII input. And of course, we are going to convert it to machine numbers, and then we're going to convert it back to ASCII before we output. So just like all the other program, we are going to start with the origination address 3000, hex 3000. Then we would have and I try to comment it so you know what each of the section means. So for the first number that we're going to record from the input, we are going to issue the opcode in, and keep in mind that it is ASCII. So when it comes into the system, you have to use the offset to make it into values that the computer would see. Okay, so we go from human text to computer number now. That means that we have to subtract, because remember earlier when you output, you have to add that hex 30. Okay, now when you're recording input, you have to subtract the 30. Okay, you got to bring it back to the hex value that's supposed to be. So we're going to subtract the 30. And in this line, instead of using x30 and subtract, which takes more lines, what we can do is we can have a label and we can fill it with a value. Okay. So here I'm going to load register 3 with a label called hex n30. That's for hex -30. So that way we can operate the subtraction with the label. It saves me a few lines. Otherwise, I have to do 2's complement and so on. So that takes a little bit longer. So so simply, it's like declaring a variable hex n30, right, at register 3. Then we are going to add register 0, which has the input from the user, with the hex -30. So that's going to offset it, and then put the result back into register 0. Okay. So we take what was input, which is in register 0. We're going to add it with what's in the label, which is at register 3. Okay. And the label is -hex 30. And we're going to store the result in register 0. Then because there are two inputs. Now we have to move it. So can I put this into register 1 to start? Yeah, I can after I add it, but I want you to show you how you can move things. So after I convert it to the hex number for the machine for ASCII, right, from the ASCII value, then I can move it to a register because I need to free up register 0 for the next input. So how do I move? I use an add. Okay. So now I'm going to take register 0. I'm going to add it with the decimal 0. And I'm going to store it into a different register, register 1. So when you need to move it to a different register, you would have the destination register and then take the source, add it with a hex 0 or a decimal 0. So here I add it with a hex 0. So that will free up register 0 for our next input. Then we have the next in for the second input. So let's say we do 2 plus 2, right? So that 2 got to be converted, and then the next 2 got to be converted, and then we're going to add it. So here I have an in. And for the next line, again, same thing as the previous. I got to convert it from ASCII to hex value. Okay. Then the next part, after I convert both of these numbers already, then I can add them together. And here I wanted to put the result in register 2, and I'm going to take the input, the second input, which is in register 0, and the first input, which is in register 1. So those are the two input, and then store it into register 2. Now, before I display it, I got to convert it back. Okay. But here, what I want to do is I wanted to also print out some kind of message to the user. The sum of the input or the sum of the value is, right? So here I'm going to load a string, and that string is going to come from message, MESG. So you already saw this in Hello World. So we're going to load the string from to the register 0. We're going to output it. Puts. Then after that, I'm going to move the sum into register 0 after I had output the message. It's free now, so I can move and recall that the sum was in register 2. So as we move, we take register 2, we're going to add it with the hex 0 and then put it into register 0 because that's where it's going to take the value for the output, no other register. I see some chat comment. Is there no move? No, not in LC-3. I know that in Microsoft and NNSM, there's a move, but yeah, this one does not have a move instruction. You can only add, load, and store. So that's a good question because other assembly language, right, would have move instructions. Okay. But when you use the move instruction, those languages, if it used the C compiler, right, it really is adding a 0 to it. So LC3 clearly shows you how you can do that by just adding, because remember, computer only adds. So we add the hex 0 to the value, and that's how we move. Because if you add 0 to 1, it's still a 1. If you add 0 to a 0, it's still a 0. It's the same exact value, but we are able to transfer it to a different register as it is a destination. Okay, so once we move it to register 0, then we need to convert it to ASCII character. So now we need to add it, right, with the hex 30. So here we are going to load register 3 with hex 30, and you will see the register 3, what the hex 30, what it means. Okay. So this allows you to convert numbers to your ASCII character so you can output. So before you output, you have to convert. When you record the in, you got to convert it to the number so you can operate the calculation. So then next we are going to take what's in register 3, add it with the register 0, so that way we can output, right? This is where we do the conversion. When you load the label to register 3, so you can convert. And then we out. Then after that, we halt execution. Then we have the data section. So my message is gonna be a string, and it says the sum of the two input is. And then my hex N30 is gonna fill with negative 30x. And this is when, right, going back to the first week, how we see negative 30 hex is FFD0. And then for hex 30 label, we're going to fill it with simply X0030. And keep the 4 digits so it's easy for you to follow. Okay, you can have less digit, but I kept it the 4 digits because it is a word. Okay, each of the hex value is a 4-bit. So there are 4 digits, so that's 16-bit, one word. Okay. So you have hex 30 is positive 30 hex, and then hex N30 is filled with negative 30 hex, hence FFD0. And then we have an end of the program. Okay, once we save this as the .asm file, then we can assemble. Don't forget to assemble. And then we will load it to the simulator. And then let me bring up my console, and then we will run. So here my input, so let's say I have a 1 and my next input character, I have a 2. So I have a sum of 3. So if it's giving you some funky sum, right? Make sure you check it, because remember, right? We are using hex. So check your number system that you're using, and also check your code if there is something wrong. Okay, so you should test it with a small value first, or 2 small values, and then get the output. Any question? Okay, so after we assemble and simulate the program screenshots, and then don't forget to answer these. So I ask you to test the value for numbers that are greater than 5, okay, such as 7, 8, right? Hex 0 through 9 is 0 through 9 in decimal. but we gotta consider the input is hex, so we would then use, so if anything greater than 5, what is the result that you get? So if I take 5 plus 5 or 5 plus 6, what do I see? Is it accurate? So just like any program, the program is only as accurate as its programmer, right? I'm trying to get my laptop some power here. Okay, so explain the result that you get when you're trying to add larger number for the using the input. And then what about the symbol? Can you input any form of symbol? So when we test these, we look for certain things like limitation of our program. If it's not able to handle symbols and things like that, then that means that you reach the ASCII scale ceiling when you're looking at, you know, a certain value. So it's not interpreting symbols, so we have to implement the code to be able to handle symbol, right, for the input. So when you test it with the symbol and it's not giving you what you would see, and how can I check, right? If I put in a certain symbol, add it with another symbol, go to your ASCII table and you can take a look at, you know, what's the sum of that would look like. Okay, and you can use the website. Okay, so let's say if I'm using this, you type in the $ plus the percentage symbol, which should be hex 24 plus hex 25, which gives you 49 hex, right? And 49 hex means that it is a capital I. So if you're not getting a capital I, then, you know, there's flaw in the program.
Professor, I have a quick question.
Yep.
I'm just a little lost on why are we trying to see how to ask it. Like the
Convert
negative,
the 30.
yeah, the negative 30, I guess, because we're going to ASCII and then going right back to decimal. Is that
Yeah.
right?
Yeah. Not decimal. Yeah. So
Or hex?
so hex, right? So when we input any number to the system, it's an ASCII value, right? But the system doesn't understand, right, the difference. You have to tell it that you are that value that just got entered into the register 0 is an ASCII value. And so the way that you treat it, you have to add the offset. So if I have a 0 character, I need to add the 30. Okay. If I have a 1, I still have to add a 30, because as you can see, between the character 1 and the hex is 30 hex. Okay, here's the hex number 30. And if I enter the 0, it's going to take that 0 and put it into a temp location. We got to treat it. We got to convert it. So we got to take that 0 and add it with the 30. So it will be 30 hex.
Okay. Okay.
Yeah, it sees everything in hex, which is eventually converted to binary, but we're using hex so you can see, right? Now, if the user input the number 1, I still have to take that 1 and add it with a 30, so the computer would know that, oh, that's a character 1 because it's a 31 hex.
Oh, okay, that's where the negative.
Yeah, it's kind of like, yeah,
okay.
you have to translate it to what the computer knows, because it doesn't understand the difference, right? Because if you don't treat it, what's going to happen is when you output, it's going to be wrong, inaccurate, it's error. Okay, because if you don't offset it, it's going to see that, oh, that's a hex 1. So we have to bring it to the hex from the ASCII. And then so when you input, you subtract, right? You take 30 minus the input. When you output, you add.
I see now. Okay, thank you for that. Appreciate it.
Yep, no problem. It takes a little bit to grasp, right? Like, because we're lucky to have, compilers that handle all of that already for us. But now you can see, right? And the process of building the compiler to handle all of that is understanding the concept of implementing ASCII.
Professor,
Yes.
can you run the program one more time? I want to see if I've been having.
Yeah, so when you get this illegal vector, go ahead and reinitialize the machine.
Okay.
And then reload your object file. It does that once in a while. Okay.
Okay.
Yeah, when you run it the second time, because it has values in there, it wants to be clear, so reinitialize it.
Okay. Thank you.
And click File, reinitialize, and then you can just click Run. See, sometime it does that. You gotta reinitialize and then load. Okay, and then run. So I just ran it with the 5 plus 5, right? And it's not able to give me an A. Okay, why do you think that is? Let's go back to the table. Okay, so a hex A, look at a hex A, what that could possibly be. And is there anything that convert a hex A over? Probably not, right? So there's limitation in this when you're the hex A, right? Here's the hex A, which is a 10, because 5 plus 5 is 10, a hex A, which is a line feed. So it's not able to give me any kind of symbol, because what's a line feed? Just a new line. So, then we can think about like how we're able to control the input of the user to make sure that they're only using values in that range that we want them to enter, right? So instruction need to be better for the prompt along with your code on how you apply the condition. So at the simplest level, the purpose of this is to show you how you can implement input and output. And also the conversion part is important. Okay, we will do more of this down the line, and you would see like, how to manage or write better code as we progress. But, first time, this is good.
Wouldn't the output of 5 plus 5 be a colon because it's 3A in hex?
5 plus 5 hex. Yeah.
Well, when you convert it from hex to get the ASCII value.
So if you take 5 plus 5, yeah, so the offset for the 5 is going to be 35. So 35 plus 35. So hex 35 plus 35 is going to give you, 6A, you're right. And then you can check what that 6A is, which is right here, a J, a lowercase j. So the program does have flaws, and I'm aware of that, right? So the point is that for the instant. Okay. So then we can fix the program or improve the program to make it better, because every program can be improved, of course. Okay, so the in statement, is it always loading the input? Yes, always from register 0, always. We cannot use any other register when it deals with output and input. When you're outputting a string, it's from register 0. So no matter what, so if you have something there and you don't want it to output, you gotta move it. Okay, but if it doesn't have what you need to output, then you gotta move it into register 0 to really output. The first register is gonna be used for input and output always. Yes. Yep. Questions? Okay, so the best thing to do to handle for is to when you test it is to look at, you know, the ASCII table along with what values you're adding, and then, you know, you can try out different things to really examine the program. But, you know, it's just a few lines to kind of show you for the input and the output. Okay. And when we go into next week, and you can pre-read the chapter, I think the authors, they added some additional, you know, all the later chapters after this is going to go into, like, you know, opcode and operands and what's happening in IR and other areas, so you can see. So this simulator was really written for this book. So you know, and this is like the easiest language to learn in assembly, in my opinion. So, you know, there are other languages that you can tackle after you get an understanding of this. Pretty straightforward after that. Okay. All right, so check out the chapters. You can pre-read, and then we'll go over some of the opcode, the operands, how to handle some of the instructions like load, add, LEA, and so on. Okay. Okay, so only 4 exercises today for lab 2. Okay, and then I will post the next unit, you know, early next week. You can take a look at that. I think I did put a link for the lab manual. I modified the stuff that was used in the original lab manual that's used by the university, because I ran into a few errors when I tested the code, and also like some instructions were kind of a little vague. So I modified that and I implement that for this class. So if you take this class, it will be equivalent to organizational structure architecture at Cal State San Bernardino. It's exactly the same lab manual that they use, unless they changed it recently. But okay. Question. All right. So I will stop recording. We do finish a little early today. Please put your name into the chat. If you're done, you can upload your lab now, or you can turn it in by Sunday. And then I did update all your grades, so you can check out your grades. If there's discrepancy, let me know, but I double check everything. Have a good night, and I'll stick around for questions.